Recording. Okay, now we are recording for real. Okay, so a little bit of context, just for the sake of historical notes. Marinho was tortured to do serialization. Which, by the way, have you moved the things or not?
Not yet.
Okay. So he did what Marinho did for the past 2 weeks was basically grabbing the the various types that Mageta and I did. Which, by the way, this video will only the video that we did that Mageta will only be available in February. So that there's that.
Okay.
Uh, and then what Marinho did was to pick those types and stringify them using the abstract data format documentation from Erlang. And he did that for 2 weeks, and he's still alive, which we were very glad, actually. And now he said that we are ready to pick a Karuta program and actually figure it out how that's going to look like in Erlang.
Yeah, so I just made a new module called Translator. We can figure out a better name later,
Okay, there's
but
immediately a to-do here.
okay.
Immediately. We need to go to the Earl module and include to the command line things the runtime.earl, because we're gonna use things from there, but they need to be provided as a file to the command line things.
Runtime.earl,
Yeah,
you mean this?
yeah. We're gonna assume those are available, right?
Yes.
So with this file needs to be included in the Earl command line things. I don't know where yet. This we can do this now or we can do this later, but we should add a to do.
Uh, I mean, as long as zero starts from this directory, that's probably fine. But okay. Uh, Translator to do. Figure out the logistics of handling the runtime lib.
Yeah. Okay, now we can proceed. What do we do, Sensei?
Sensei.
Okay, so basically we need to make a function that takes a list of declarations, because that's what the preprocessor spits out, right? Declarations and queries, basically.
Isn't this compile prime function in the executor? Uh,
Executor. Um, yeah, this is calling. Oh, we actually have a compiler module. Maybe we should just use this instead of making a translator thing.
yeah, that's kind of was my intention because I think I was the one that made this compile and I added it to do there. Well, that was very poor. I should add a more descriptive to do, but
Okay, yeah, we basically need to implement this compile function.
yeah, yeah,
Lemos, just I'm
sure.
gonna use your wisdom now to ask you a question.
Okay, that's scary.
Should I have no operators at all and just make everything unifications with relations? Tell me that sounds like
Uh,
a bad idea because it's not easy to implement that.
Wait, I need to understand the first. What do you mean by
So
having
like
operators?
less than can be an operator, like
Ah, like the
literally
plus
typing
thing.
plus
I
exactly.
remember that.
So
Okay,
everything is just a predicate.
my understanding is that there is no way around it because in order to do the type checking later for the schemas, you will need to do them relationally, no? Anyway.
Yes, you got exactly the point.
That's not mine.
Of
That's yours.
is it?
Yeah, you said that.
Okay. Uh,
I
I want to
particularly
try.
remember. I think it was in the restaurant.
Was it? I don't remember, but okay. I am smart if I said that before.
Yeah, you are. Okay,
We shouldn't
let's
agree
go,
with that.
Mani. So I remember last time I saw this file, we were implementing the current file logistics. Like, if you provide a bunch of files, we need to remember which one it is, because we need to put that as the name of the module for the Erlang compilation, something like that.
Yes, we
I
do
think it's
need the
line
current
38
file
there.
for that. Line 38, yeah.
Awesome.
Um,
Okay, so now what do we do? I think we need to do pattern matching on the list now. No?
we do, in
The list is
fact.
literally being ignored on line 46. It's the underscore on the left side of the comma.
Yes, yes, indeed.
We're essentially going to keep appending, right, to this output.
Yes, I'm thinking
Okay, so this is tail recursive. Nice.
it's gonna be tail recursive, yes, but I'm thinking the actual function that loops, that calls itself, cannot be this one because this one needs to append the module name at the top of the file, and
It's
that
already
should,
doing
should
that
only.
in the initialize.
Oh, it is actually.
Don't want to distract you guys, but I'm just gonna put my screen here.
Sure. Sure, sure.
Man, it's been so long. It's kind of slipped my mind actually. So okay, this is actually good then.
Yeah, this is
That
only going to
means
be a pain in the ass when we implement multiple files, right? Because we're going to have to do this initialize behavior for every file, not only the first one. And initialize is
yes.
kind of being assumed to be the first one. But that's a problem for the future us, so that's okay.
Okay, so actually compile can be the actual loop. In which case that means
I think base
uh,
case first, so empty list. And my understanding is that we just spit the output.
yes, that is correct. Um, if we have a compiler, um, to do for a second, let's just see.
Is this gonna work? You
Uh,
have two cases of empty lists.
yeah, this needs to be form colon colon remaining.
You probably should add underscores in the beginning of or at the end of those names.
We're gonna need to use them though.
Oh, okay. In that case, you can just start pattern matching the form.
Hmm.
We already have this pattern matching in the other Karuta project. If you want to copy paste from there, that's okay.
On the other Karuta project.
Yeah, in the
Oh,
first WAM version.
uh, no, I'm just wondering. I think actually this is gonna need a. Oh, it doesn't. Okay.
Don't forget the semicolon underscore
Semicolon underscore.
if
Yeah.
you're not gonna use anything else. Okay. Okay, so now what do
Actually,
we
this
do?
should go here. In fact.
You don't need a parenthesis for tuples in pattern matching, by the way. But no, but that's okay. You already are not doing that anymore.
Okay, so we have the current form. We have the remaining ones. I know for a fact that the last thing we're gonna do is we're going to compile the remaining compiler with output.
Yeah, pretty much. You need to put a rec somewhere. I think in the first let in line 30 probably. Wait, but
And
why are those two functions tied together?
they don't need to be.
Yeah.
Let rec compile.
Yeah. What is the problem?
And this needs to be a tuple.
Makes sense. Awesome.
Compiler with output equals, and then we're gonna do something fancy here. We're gonna need to do. We're
Wait,
gonna need to
I thought we were
do.
gonna pattern match on the form first and then do that. You want to do everything in here, inside these equals here?
I don't think we actually need to do more than this in this function because we should be able to compile each form independently of all the others, I think.
Yeah, that's why I thought we would do the pattern matching on the form.
No, we can do something like let rec compile form or whatever, right?
Ah, like we did with the registrar locator back in the day. I think.
Yeah,
Okay.
yeah. Um, hmm. Actually, this should just be able to take. Now that I
NEST
think
clause.
about it, yeah, it's gonna take an AST clause, and it's going to take. Uh, and it's going to take a compiler, and this is going to return
A tuple.
another compiler.
Oh, just another oh, you're gonna return with the output already. I'm stupid. Yeah.
In which case, actually, we can just do
Compile
compile
form.
compiler,
You don't need the structuring
and
anymore there.
we don't need the structuring anymore. Exactly.
Awesome. Okay. Replace the line 47 probably with an end instead of a let rec.
Line 37,
47. 40.
47.
Yeah, this should be an end, not a let rec, I believe.
No, it's because there was no expression here, actually.
Ah. Oh, these are not mutually recursive, so it's okay.
Yeah, they don't need to be. So, match form with.
Yeah, that is the one that we already did before, but we can do it again, that's okay. Man, does OCaml have... I only know the name in Haskell. I don't know the name in F#.
Sorry, what did you say?
Okay, so there is a thing in Haskell called view patterns that allows you to call a function immediately receiving the argument and then doing the pattern matching with it. I don't know how to better explain that.
Active patterns?
Yeah, I think it's active patterns in F#.
I
Because
don't know how that works in OCaml though. That exists in F#.
yeah,
in
because we
OCaml,
may
I don't
want
know.
to remove the location to do the pattern matching more easily, Marin. That's why I thought of view patterns. Because the forms have location.
Oh, right.
So it's a little bit annoying.
That's actually a good question. Is there such a thing in OCaml? Oh, there's of course a PPX, Lemus.
Ah, of course.
PPX view pattern. That's it.
Okay, it's using even the Haskell name. Okay.
Let's just
That
match the
sounds cursed.
content because right now the beam AST doesn't have location data,
Yeah,
unfortunately.
no, this is definitely okay. Form.content, awesome.
So let's see. What's the type of this thing?
It's an A, of course.
It's a
You need to
freaking
grab,
A.
yeah, you need to grab from there. It's a clause prime, which means that it's 9 and 10.
It's either a multi-declaration or a query. Okay.
Which one you want to start with?
Multi-declaration.
Yeah, okay.
Query.
Yeah.
Okay, so for the multi-declaration, actually,
I think the multi-declaration is a tuple, the underscore.
compile form you use. Oh, right, it doesn't call itself. I
Yeah,
don't
this
think
doesn't
this
need
needs
to be recursive, yeah.
Yeah, it doesn't. Okay, this builds. So, multi-declaration. This needs to take.
It's two things. It's a declaration, and I think a list of declarations after.
That's the head and the body, I think, right? Actually, no, it's the.
It's to force this to not be empty.
Right, it's the first declaration and then a list.
Ah, no, 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 you're right. It is the head and the body. The first declaration is the. What is
No, this is
abdecal
just.
again?
No, you're correct. This is just to force this to not be empty.
Oh, okay. Yeah, but why is the first one without location? Ah, because
Because
we're gonna
there's a
use the head,
location
right?
on the outside here already.
Ah, I remember that. I remember that. Okay, that makes sense. We gotta be clever about that. Like we need to remember.
Mm. 1 second. I need to plug my headset because it's beeping.
Sure. Which, by the way, Marinho, I figure out that my cousin has the same headset as me and you.
That's nice.
And I already told him that the microphone mechanical muting system is gonna blow up.
That's very tragic.
Yeah. Okay,
Why
cool.
do I have to use LibreOffice to read the document? My professor forgot that you have PDFs, right? So there's
Oh,
a magical
he's not
thing
using
called PDFs.
PDFs.
No, he writes Microsoft Word documents and sends
That's very
over.
cringe.
It is.
Ugh. Ah, nice. Yeah, we are doing the same trick that we did for the registrar locator. That's not gonna work because the rest is also already a list. And there's another problem. The rest has a different type than everything else, so that's also not gonna work. My bad, Marinho. No, no, no. You cannot strip. You cannot strip the location because this is still Karuta runtime, which means that we may have to use it to report something.
Um, this is true.
Are you sick,
Actually,
Marinho?
do we?
Mm-mm. No, I'm not.
Because like we're not doing any kind of static checking at the moment, right?
Well, but there are checks that we will be able to do, even though they are not. Like we don't have static checks yet. Some checks we can, some static checks we can do right now, such as a preprocessor.
No, no, but the preprocessor is already handling its checks. This is after the preprocessor.
No, yes, I'm just saying that as we did with the preprocessor doing static checks, I imagine that we may also have the case with compilation. No?
Would we? Because like the compiler function is going to translate an AST, a Karuta AST specifically, to the beam,
Yeah, exactly.
but
Let's say that you're using a predicate that is not defined anywhere. That's gonna parse and that's gonna preproce, but that should blow up in here.
should it blow up in here?
Well, or either that or we add such check to the preprocessor, which sounds a little bit more expensive.
Isn't the Erlang pipeline going to check those things regardless?
Yes, but here's the catch. This is like a foundational question that I was talking to Nathan. I was complaining about the JVM, and then Nathan said, "Lemos, just do the checks yourself. Don't rely on the reporting from the VM." And I was like, "That sounds like masochism." And he was like, "Life." So if we don't want to make our programmers suffer from the bad error reporting that we suffered from the Beam, we would have to do those checks ourselves. You see the trade-off here?
Okay. Well, in that case, it's probably better than to instead of
Hmm.
um,
You don't need
we
that
need
lambda,
to
by the way. We also have already made that lambda for you in the location module.
location dot um,
Strip lock.
No, not strip. I actually want to re-add the location here.
No. Well, I was just mentioning that the lambda that you wrote, we already have an like a convenience for you. This is a type that's not gonna work. To re-add the location, we don't have an convenience for that. We can make that function right now.
Location.
Oh, oh no, we don't. Okay, I thought it was the add, but it isn't.
2T.
Yeah, this is to convert
To
between the
position.
the lexing module from OCaml to our stuff. And I don't particularly remember the reason why we had to do that. Why we had to do that? There was a reason. But
Can't you just do this then? Like using inline records, like content
yes, sure, we definitely can do that.
equal first, lock equals location. Actually, form.lock.
Yes, you can definitely can do that. You probably need to open the location module though.
Let open location in.
Great. Man, it's very amazing that I still remember how to do OCaml.
Let
That's what happens when the syntax makes some sense. It's not completely arbitrary, like just a bunch of arbitrary tokens floating around.
and this one actually needs to be
I
recursive.
sure agree.
Actually does it. This takes actually this needs to take the compiler as well. Yeah, and this can be recursive. Compile declaration takes clauses and takes a compiler. Um, and these are declaration clauses specifically, so let's note that down. List, and the compiler is T, and we return a T because we are British.
Yeah, that works. Yes.
Actually, should we match the clauses? Should we match the clauses?
I don't think we have a way around that.
Because here's the thing. The entire list of clauses is going to turn into a single node on the beam level.
Oh, so you're debating about matching it or folding it, or mapping it, I guess.
Let's go to the builder for a second, because we need to build one of... Where is it? String of clause, blah blah blah. We need to build... we need to build one of these, actually.
That makes perfect sense. Yes.
So it has a name, which is a string, it has an arity, and it has clauses, which is a list of clause.clause. We need to, at some point, revisit the AST definitions in more detail, but let's see. Okay, so let's just do... Hmm. Hmm. Okay, we need to grab the name of the predicate and we need to grab its arity first. That's the first thing that we need to do. Declaration
Declaration has both of those things
has both of those things.
in the head.
I think, yeah, in the head. We can just take the head. That means, in fact, let function name equals clauses Hmm.
what are you about to do? I'm very curious. Are you gonna do what I'm thinking?
Uh, because I want this to be a list, in fact, it's probably better. Not this, I mean this. It's probably better if we just take the name and the arity as separate arguments, because here's the thing. Um, Up here, we know for a fact there's at least one element, right?
Yeah, I would propose to just keep the pair, but put the location into the first. Like remove the cons, put a comma. That's it.
Okay. Okay.
Ooh la la. Interesting.
First clause, remaining clauses. Um, Asterisk.
Yeah. Then you can actually now guarantee that the first clause has stuff in it. Head, 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 head. No, you grab the
Uh,
body first. It's just head.
oh,
Yeah.
so take the head.
Which is a func, and now you grab the name, which I believe is name F.
Let. Um, oh, this is not really. Let's give it a proper name. Pred name and pred arity equals.
You can do the structuring on the head in a single line. I think that's better.
Yeah, that's probably better actually. Uh, this is the correct order, right?
Yes. But it's
There's
not
no
comma,
field
it's
name
semicolon.
F. Oh, right. I need to take the head.
Yeah, it's gonna look a little bit ugly if you do it in line like that. I was proposing to do it like in line 45 instead of 44, but that's okay.
That's probably better actually.
You have an extra parenthesis. Yeah. No, no, no.
There we
You
go.
need to remove parentheses. Yeah.
Hmm. Okay, so
Okay, so you do first clause dot head, and yeah, exactly. Here, no, no, no. The head you're gonna do on the right. Here is name F and other things.
name F is spread name and arity. What the heck? Let's just use the thingies.
Yeah, you need to remove the
This can
name
go
F
away.
from there. Yeah. That should be enough. What's the problem?
Unbound record field.
You need to do an open of the AST module.
I need to do an open. That's kind of sad.
No, no, no. That's the wrong type. It's AST.func.
Oh, there.
Mm-hmm, mm-hmm. Great.
Uh, okay, so we need to build one of these, which means do
We
we
need
have?
one here, which I don't think we do. Well, at least we didn't have last time I checked.
We do function declaration. So builder.
Are you sure it's
And
not
this is
beam.builder?
Oh yeah, it's being.builder.
Okay, what's the problem? String
Take a string, take
int.
an int.
This expression has type T, but an expression. Oh, this is the return type. That's the problem. We need to put that in our output.
Yeah, we need to do compiler with um,
We need to extract the current. Yeah, we can do it like
we
that.
need to we need to do a finger tree dot snock declaration. Yeah, this is the basic structure, and then here we need to do something
Yeah, that's
basic.
what I was about to ask. This should not be empty.
It should not. And in fact, the arity here shouldn't be the arity that's declared here, because besides the actual arguments of the predicate itself, we also need to pass some extra arguments for bookkeeping on our side. Like we
Yes.
need to pass the lexical environment with all the bindings.
Mm-hmm.
We need to pass a number, which we're going to use to select which clause we're going to use, because we can't just use the normal pattern matching since it doesn't work with our variables.
Yes.
And we also need a list of choice points. This is actually what I was thinking about before joining here, because if we just um, if we just use maybes expressions or try catches, we're actually going to use maybe expressions because they are easier. But if we just use those, then we're not actually implementing prolog style choice. We're actually implementing committed choice, which is slightly different.
Okay, so we
Um,
need to add. Go on, Mageto.
no, it's finish, please. It's something I talked to Marin yesterday that I just figured out how to solve.
You can go ahead. I just finished my train of thought.
Yeah.
So you recall the talk about the not being a high order predicate?
Yes.
So I was thinking of how to make that lower, right? Just an actual relation on domains, and there is actually a way. You need to pass the universe in which the negation goes from. So it is basically just a difference of sets. Now you need a mapping function, of course, to manipulate the elements from one right to the other, because you need to deny each. You need to convert each element to present a mapping of what each element on the domain maps to the codomain, which is the universe that has the absence of the elements of the first. You see.
Right.
But that's probably what I will do. But that means that I'll need to stratify the world, which is something that Pascal told me, because the original idea is to have, like, there's no such thing as mutability, but it's an applied science, right? Basically, so the only way to do it is actually by considering multiple sets. That the transition of state is basically just a cardinality from a stratified universe set that you can just pick whatever through the axiom of choice.
Hmm.
Now, how the heck will I do that? I have no idea. So anyway,
Yeah, good luck. That's highly non-constructive.
yes.
Good luck.
All right, so I'm going to do another helper function. This one is actually going to do the recursion. And have you ever seen a recursion on lists, Lemos, where there are three cases instead of two?
Yes. Empty, singleton, and everything else.
Yeah, we need to do that because that's how we implement proper tail calls.
Okay, but I have a question. Shouldn't we put on line 50 arity plus 3 then?
We should actually.
Yeah, but here's the thing. The 3 is kind of magical. We should document that somewhere.
We probably should, yes. Actually, let's do this here for the moment. Let extra arguments equals 3. These are additional arguments used by the runtime. And this way we know actually what this means, right? And then instead of doing arity plus 3, we do arity plus extra arguments.
Yeah.
Arity plus extra arguments, okay. Then we need to do let rec compile compile body, why not? This is going to take.
Okay, now we are compiling the body of the predicate, right?
Yeah, so we need to translate the body into something that the bean can understand. Okay, what's the input type? We have a list of clauses, but we
I'll be
actually
right back.
don't care about the full clauses, do we?
What do you mean the
Actually,
full clauses?
we kinda do, right? Because each declaration has the head, and that's where the argument list is.
Yes, the argument list is in the head.
Do we actually need that though?
I believe so, because how are we gonna create an Erlang function if we don't know the name of the arguments?
We can generate them.
Uh, if you do that, you're gonna have to do the mapping on the body as well.
Yeah, that's actually kind of annoying, now that you mention.
But that sounds better though, because one of the things that I learned the first time we made an interpreter is that a lot of things in real compilers are like randomly generated to avoid a bunch of things.
Well, in this case, it wouldn't be random. We could just go like arg0, arg1, arg2, whatever, right?
Yeah. That's also an okay strategy. At the time, I think at the time we're dealing with name collisions or whatever. And one of the suggestions Nathan brought was to just put a random thing. But you have to keep you have to bookkeep that.
I think in this case, it might be okay to just use the variable names as Erlang variables because like Erlang has the same convention as Prolog, where it's uppercase, you know?
Yeah, that's kind of convenient, isn't it?
It is.
We are kind of exploiting what Magetta hates, which is the fact that they inherited the syntax, but the semantics changed. That's kind of funny.
Mm, I wonder if we need a compiler here. I don't think we do, actually.
Probably not yet. We will, because we're gonna have to report to the Erlang the current file, but not now.
Let's add a count here and let's set this to 0. Okay, so match clauses with if it's empty, what should we return? This needs to be a list of form.clause.clause. So actually, let's put that here. So this is an ast.deco list This is an integer, and this returns beam.form.clause.clause list.
We probably should do open beam in this entire file. But okay.
Should we? Actually, builder dot form. That's not it.
What's the question?
Beam core Erlang clause. Okay.
What a type.
What's the problem here? Expecting in. Actually, let's omit the return type because this is only gonna be used in one place.
Well, that relies a little bit on the LSP then, but that's okay.
Uh,
Okay,
okay,
so
what
what
are
do
the
we have?
problems?
Unused rec flag, that makes sense. Match clauses with, it's non-exhaustive, makes sense. Content, this record expression is expected to have type AST_DEC. There is no field content with type AST_DEC. That is true, actually. Line 51 is specifying that the tuple is an AST_DEC and DEC actually doesn't have. So you need to add the location stuff. So you do location dot with location on the first member of the pair in the type on line 51.
Oh, line 51. Okay.
Yeah, but that's going to be a little bit weird. Wait, don't do that. Let me think a little bit, because I think REST is also fucked now. Because of the same problem. What is the type of REST? Yeah, that has location, and the type on line 51 doesn't have location.
There, problem solved.
Compile body. Now, same problem. Line 47 is specifying a declaration, but we are actually sending stuff with location.
There we go.
Yeah, I'm not completely
There.
useless. I can still program.
Okay, so if the clauses are empty, then we return empty, I think. Should we do that? Should we do that? I think so. If we have a tail call, actually, well, this is not really a tail call. This is the final clause.
Yeah. Wait, why does it matter, the singleton versus the rest?
Because the singleton, we need to not create a choice point, so it's a proper tail call.
Wait. You have a Karuta predicate. We have a head, and the head, it has only one clause in the body, and you are telling
Not a
me.
clause in the body. There's a predicate that there's only one declaration for it,
Yeah,
right?
it's like functor, arrow, functor. That's it. Dot.
The body could have multiple things, but the point is there's no choice point because there's no other clause to retry if this one fails.
Ah, we are also dealing with the multi-declaration being already grouped.
Yes.
Ah, okay. I forgot about that. Okay, that makes sense then.
Not create a choice point. Oops. Actually, yeah, this needs to be like this.
Okay, so in this case, we do have multiple choice points.
Um, yeah, because if we have multiple clauses, well, the base case is when there's only one clause, which is the last one, right? But then if there are clauses before that, they must introduce a choice point so we can return here and try the
Ah,
subsequent clauses, you
man,
see?
that's very interesting. The approach that we're taking in comparison to the original version of Karuta is kind of backwards. We introduce choice points really at the end of everything, but now we're introducing choice points as the first thing.
Yeah, actually, let me try to write an example here so it can be more clear. So,
Yeah, no, I definitely remember.
okay, let's use this as an example, okay? So like, I'm just gonna paste this here. So what should this look like, right? This should look like something like this, okay? So we're gonna have a plus z, right? And this is
Yeah,
our length now.
yeah.
Actually, let me
You can,
comment
yeah, you can
these.
comment those, yeah.
Yes, so we are not confused. Karuta.
Yeah,
Okay, so we're gonna have to receive the environment here as an extra argument.
yeah.
We're gonna have to receive the choice
Yeah, that's actually my first question. I thought the choice
points.
point lists would be inside the environment.
It could be.
Didn't we implement the runtime assuming that would be the case? Like I
Mm,
remember pretty vividly.
that was when we had a separate process for the environment, but we don't anymore.
Yeah, exactly. It's everything inside a single state, right? Everything,
Yeah.
including the choice points, right?
No, no, there are no choice points anywhere here. This only deals with bindings now.
Ah, that is the difference. Before, this runtime stuff was also doing the choice points.
Yeah.
And then we decided to actually gonna do that ourselves. Okay. Okay, that's okay.
Okay, so we should do env choice points. We should have a zero here because this is the first clause. And then we have the arguments, which are going to
Can't
be
we just grab the length of choice points?
no, actually no.
No.
Because this is pattern matching on the arguments that we're gonna pass to plus when somebody else eventually calls it.
Yeah, but why do we have to put an identifier to the choice point?
Because we will need to manipulate it actually.
Okay, continue. Maybe you're gonna answer my question later. So just go.
And then, okay, here's the first bit, and actually, I just remembered why I didn't want to use these names here. Um,
Yeah, because it's fucked, right? The
it's
way that it
because
is.
like we have to do something like arg0, arg1, arg2, and then oh, folks are joining. Hello,
Yeah.
Vinicius, and hello, Mr. 8 a.m.
Yeah. Hello, folks. Continue, Marinho. Continue.
Yeah, the reason we can't just use out
Yeah, yeah,
0
because
and
it doesn't
out
work. Yeah,
here
it doesn't work like that.
is because this might be a logic variable that's bound to 0, and that should work, but this will fail because at the runtime level, a logic variable is not a number, so
Yeah,
it
but
never will unify
would
with 0
the
here.
double out work in Erlang?
It would actually, but it has the same problem of it's not gonna take into account any logic variables.
Yeah, no, yeah, that one makes sense to me. Yeah, what you said makes sense.
So we would have to do like Karuta.
Man, it's gonna be annoying as fuck. But okay.
Um, Karuta unify, right? So first of all, this entire body needs to be inside of a maybe.
Okay. Interesting. What is the reason we're using the maybe instead of a case in this case?
Because we're gonna do a bunch of this. Okay, next env, actually, yeah, why not? Env0, whatever.
Sure.
Karuta unify. Actually, for consistency, let's put env0 up there. Env0, arg0, arg2. Then we need to do okay, env2 question mark equals Karuta unify env1 arg1 0. Right, this is basically doing those bindings from the arguments up here, right?
Wait. Ah, no, actually that makes perfect sense. Okay, that actually makes perfect sense, Maria.
Yeah, so we're unifying the first and the last arguments. We're unifying the middle argument with 0. And then we're gonna tail call net with arg0. And we need an else here, because if we get a unification error at any point, and we do unify blah blah blah, yeah, if we get error unification failed, then in that case we should call plus with env0.
We need to call the second choice point.
Yes, indeed, and in fact,
We need to pop it. We need to pop it. Right?
Yes, we do.
Yeah, we need to pop it. You need to check if the choice points is empty or not. Actually.
Actually, this needs to be env2. This needs to be yeah, this needs to take the env2. This needs to take the choice points, and this needs to take the 0 as well. This is going to be, these three arguments are always going to be inserted by the compiler, so the user doesn't have to worry about them. And then, before we do this actually, we should in fact do this. And I haven't decided yet how exactly this data structure is going to look like, but it's definitely going to be a list, and we need to do something like, I don't know. We need to add a record of what to do in case we fail in this net, basically.
Why? Oh, because if net fails, we need to go to the next choice point. And this is tail call, which means we're not gonna pattern match. Well, we could, which is would be convenient. You see what I'm saying? Like we could do an okay env3 or whatever.
Yeah, actually, I'm not sure if this is strictly necessary in this particular case.
Yeah, if the choice point is empty, we should completely blow up, right? In this case. If net fails on 36 and the choice points list is empty, we're done. You're done.
Actually, no, if the choice point fails here, we should actually go to the next clause. So we should.
No,
yeah,
but that's why I said if the choice point is empty.
No, because this is introducing a new choice point, because this predicate has multiple clauses, you see?
Wait, so you're telling me that choice points, we are constructing it, not using it?
At this point, we are constructing them, yes.
Ah, okay, that was my confusion.
Um, so we need to record that we're calling plus. We're calling it with, well, arg0, arg1, arg2, and we should go to the one case because we just finished. Well, this is going to be the end of the zero case if this succeeds, right?
Yeah, I have a question. How do you plan on implementing net then? Like net's gonna take all of those things?
Well, we need to.
Okay, but that's gonna be like, how does that work if net was not a built-in, man?
If
Let's say instead of net you're calling a predicate that the user defined, right?
Well, then that predicate is going to be compiled into something like this that also takes the three extra arguments.
Ah, okay, I see. I see. Okay.
Yeah, and then in the else case here, if we get a unification failure, and I'm pretty sure there are like no other errors other than unification failures at this point. In that case, we tail call ourselves, but incrementing the clause counter to 1, and because then we can do this, plus m0 choice points 1, see?
Yeah, but the error message of that's gonna be garbage, right? Because if there is no one, like the error message on the beam side is gonna be nonsensical, right? To the
No,
user.
because we treat the final case especially.
Ah, okay. Okay, but how do you know? How do you know ahead of time how many cases you have if you're constructing it right now?
Because this is a translation of this program, right?
Oh,
Which
so you
means
already
we're gonna
know
have.
that she's not a singleton or it's not empty. You already know that.
Yeah, we already know that this is a multi-declaration with three clauses,
Ah,
basically.
okay. I see the vision. Okay,
Yeah,
awesome.
then for the yeah, then for the one case, it's basically the same thing except it's unifying arg1 and arg2, right?
Yeah, just
Because
copy paste
this
this.
is
Yeah, just copy paste this the body of the first plus into the second and swap it. I want to see the final version. The well, not the
right.
final
This
version.
is
The plus
arg1,
the third plus.
arg0, and this would um yeah, this would be it is not quite right, but whatever. And then the final case, which is oops, and then the final case, which is the interesting one,
Yeah,
plus um,
same stuff.
same stuff is 2.
Yeah, change
Um,
two on 46.
on 46, yeah, this needs to be 2 as well, and this needs to be 2 here as well. So in this case, this is actually slightly different, okay? I'm gonna copy this maybe here for now.
Okay, very interesting.
So what's gonna happen, okay? We need to unify this argument with this, right?
Yes.
So we're going to unify arg0 with suck of. Actually, we need a fresh variable, don't we?
Yeah, we need to start a fresh. Man, that's gonna be annoying. We need to figure it out. Like, oh, this is a fresh variable. Let's call fresh. I guess with time we're gonna get like we're gonna speed up this thing and then we're gonna get used to it. But until then, holy fuck.
Uh, bindings. Okay, this returns a var, and this always succeeds. Okay, so var 0 env1 fresh env0. Yeah. So we make a variable for the previous.
Yes.
Then you need to do var 0 here.
Yes.
And this is, yeah, this is env1, and this is env2.
I don't remember. Did we implement functors as tuples in Erlang?
We're going to.
Okay.
That's actually
Cv
what we're going
initials.
to. That's part of what we're going to do in this translation step, actually.
Oh, okay.
Okay, and then this is basically it for the for the environments here, because now we have to tail call plus, and conveniently we actually don't need to explicitly turn this into a variable. We can just pass this in line because of how unification is implemented, right?
Yeah.
So we can just tail call. Um, we can
Plus
just tail call plus. Um,
env2 calling ourselves, but it's probably plus 0, I believe. Oh, just choice points?
just choice points because this is the final case. If this fails,
Ah,
if
yeah,
this
yeah,
case
yeah. Makes perfect
fails,
sense.
there's
Makes
no
makes
backtracking.
perfect sense. I still don't understand how, like, to
There's no
me,
else here.
yeah, there is because you can fail to unify 51.
We can fail to unify 51, but in that case, you just return the failure and bubble it up.
Yeah, but then it's gonna be nonsensical, isn't it?
Why?
Because this is gonna the maybe error will blow up to the user
No, no, no.
saying
This is not going to blow up. This is going to return an error.
yes, that will return an error. That there is no there is no treatment, right? There's no else here.
Yeah, if this doesn't match with this, it's just going to return whatever this is.
Exactly, and that in Erlang will blow up in the Bean runtime with a message
Mm,
that may be nonsensical.
no, actually, this is just going to return the error, Lemos. This maybe it doesn't actually throw exceptions. Like if you do this maybe bind here, this question mark equals, and the left hand side doesn't unify with the right hand side, it's just going to return the right hand side out of the entire block.
Okay, but who is gonna care about that then?
The caller of plus.
The color of plus. Yeah, it's not clear to me what the color of plus will do in this case. But
var0 successor of arg1, and this is going to be arg2. Yeah, this is basically the interesting case right here.
okay, questions. It's still not yet clear to me how line
You're back.
36 and 44 will be implemented. Hello, Magit. Because here's the thing. When we call not, right? Uh,
Oh, we can implement the primitives directly in Erlang. That's not an issue.
no, yes. In this case, we can implement the primitives directly, so that's completely fine. But then it comes back to my question. What if the final tail call is actually a predicate defined by the user, such as like +2 or whatever?
Then it's going to turn into, there's going to be one of these that the user defined somewhere else, right? And we
Yeah,
just
but
call it.
we're never using the choice points. We're only appending them. When
Uh,
are we using them?
when are we using them?
Yeah, you're doing
Well, in
line
this,
36. You're adding +1, arg0, arg1, arg2. But where are you using that?
well, in this case we aren't because plus always tail calls, right? Um, Actually, that's a good point. We should probably return the list of choice points together with the as part of the protocol here, actually. Um, let's see, plus Karuta. Okay, this, right?
Mm-hmm.
So this basically. So like, um, assuming that blah blah blah, we have this boilerplate, and we already seen that. Basically, the return value here, because int is a built-in, right? Um,
Yes.
inside of the body of net, as the tail call here, we're going to do something like we're going to do something like um, maybe and we're going to have like um, true question mark equals is integer, right? Because this is a built-in predicate
Mm-hmm.
of the arg0. And if this is true, then actually we can just return, and we should return
Okay.
okay, and we return the choice points. Choice points.
Mm-hmm.
Because the caller here, if it's not a tail call, right? The caller here is going to start using these as the new choice points, because then if it needs to backtrack, it backtracks to whatever we put here.
Yeah, I understand that. I understand that. But I still don't understand. It's not clear to me yet how the backtracking is gonna work with this appending of the choice point system.
We need to, when we emit the query, which is going to be the entry point for the entire program, right?
Yeah.
Um, the query is going to be is going to need to be treated especially because we need to actually make a loop that when we fail some call, we need to be able to use the latest choice points to try again. You see?
Ah, okay. So the query is the one that's gonna be popping the choice points.
Yeah.
Ah, okay. 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 I definitely understand better now.
Oh yeah.
Okay, okay. Let's go back to the plus. Are we gonna let's start with that. So I my understanding is going back to the OCaml code that we need to add. Well, we're gonna need to do the renaming. That's a given, I believe.
Yeah, we do.
Such a so sad, but okay. And I need to map them. We need to kind of map them. Okay, so let's go back to the OCaml code. Where should we start? By the maybe expression, I guess.
Um, yeah, we need to do. We need to do.
Let's implement the singleton case first. That's easier.
Yeah, let's do the base case first. That's definitely easier. So if we have a final clause here, which has a location, which we may care about.
Yeah.
Um,
I think it's just content, not contents. Yeah.
okay, so the content here is going to be decal, which has a head and a body, right?
Yeah.
Uh, head, body, and these are not commas.
Equals content equal, yeah, that. Yes.
Okay, so for the head, we hmm,
This is the head of the declaration itself.
yes, it
So this is
is.
plus.
Yeah, this is going to be a functor which is plus with the arguments basically. Um, I'm thinking if we shouldn't do the variable renaming here, actually.
Probably.
Um, right, so first question, should we actually have separate names for the... Because in this example, for the sake of clarity, I had give separate names like this is arg0, arg1, whatever, but then the locals, where is the local? Yeah, here. Here, this is called var0, right?
Yeah, I
Um,
don't think it matters, but I think for our sanity, we should keep them separate for debugging purposes.
we should keep them separate for debugging purposes, okay? But then, what do we do about... Actually, we don't. That's kind of... Okay. Okay, so in that case, yeah, we can do that. So we should generate arguments. We should generate arguments. Um, Man, we're gonna have to implement a lot of logic dealing with variable names again, basically.
You'll be fine, Manning.
Man, what I just discovered? We're not gonna. Okay,
Right.
before I say it, I'm gonna preemptively say we're not gonna do it. Okay? But you can actually name variables in Erlang with emojis.
That sounds amazing.
That sounds well. Props for actually supporting Unicode, I guess. But also, why would you do that?
Man, if you look at the Beam program afterwards, like, come on. Are you telling me that's not gonna look hilarious?
I mean,
That would look so hilarious, man. Anyway, I just want to throw that out because the first thought, like, I'm so Magetta brain that that's the first thing that I searched.
Okay.
Let's do the renaming, Mari.
yeah, let's actually do that first.
We need to create an empty map, right?
We should probably do a helper function actually because we're gonna use it in a few places, I think.
Yeah, it should grab
Let
a list
um,
of strings and return a map of a string to a string.
a list of strings. Why?
Because if you have the functor, the list of arguments will be a list of namefs, right? Each
No,
element
because
being another functor.
no, because the head is actually a list of functors.
Exactly. And what is a functor? What is a func?
Or rather, the head is a functor, but the elements is a list of expressions, arbitrary expressions.
No, you're right. Okay, so there needs to be a map from expressions to strings then.
Yeah.
Yeah, no, that's okay. Man, how bad is that's gonna perform? But okay, because we're gonna have to fold over them for each one of them.
Actually, no. We can just compute the mapping from source code variables to compiler variables once and just use that map repeatedly.
No. That's not what I meant. I didn't mean that we are like wasting computer resources computing the same thing. I'm just saying that for each declaration, well, rather each functor, we're gonna have to do this thing, right? For every one of them.
Mm, yeah, we are going to have to iterate over every one of them. We're going to look at the head of the declaration to handle the argument list, and then we're going to iterate over the body to handle all the locals, basically.
We can optimize that by making the parser do it.
And there may be some locals already in the argument list, because if you don't just have 3 variables, if you have actual structure there, we need to handle that. And that generates extra locals for the contents of the functors.
Yeah, but let's put this optimization for later. We're gonna iterate at each one of them, even though the parser could do it. Oh, you're gonna pass the
Okay.
entire head to it. Okay.
Well, you need to pass the entire declaration because we should also we may need to handle locals in the argument list, right? And then since we're handling those locals, we may as well handle the locals in the body too.
Okay, so we want to make the args and the vars here.
Yeah.
This should probably be. This sounds like the pattern of having like another inner function that has a counter.
Actually, I wonder if we should do some desugaring, in fact.
What do you mean?
Um, like, because right now, the declarations here, they can have arbitrary expressions in the head here, right? And in each call um, of the body. For the body, that's fine, but for the head, it would be convenient if we only had variables, actually, because that would make our lives easier.
Oh, but that's not like we should allow you to have things that are not only variables. They could be like lists or other things.
No, yes, but at this point of the compilation pipeline, it would be convenient if we didn't have those. So, um, should we add a desugaring pass doing that?
Then I'm confused. What are you calling desugaring those?
Like, unless the
The
unless the arguments are all variables already, we just turn them into variables and we add clauses to the body to do the destructuring that the user intended for the arguments, basically. Because we're gonna have to do that at some point anyways, because we need to do it at the beam level
Could you give
eventually,
me an
right?
example? Actually,
Okay,
no.
if you
The
go
successor example of the plus, the third plus, isn't already doing that?
the successor example here. No, the idea would be to turn this into something um, like um, arg0
Yeah.
and then add a clause here saying, well, we don't have a proper equals here, but we could add one like eq arg0 suck previous.
You're missing a bracket. Okay, so your proposal is that we literally change the things to only be variables on the argument list, and we do the pattern matching like Ooga Boogas.
Yeah, no, if we have an argument list which has anything other than a variable, we replace that with variables and we add the equalities to the body.
What is the alternative to that?
The alternative is to do it while we do the translation to the beam.
I understand what you're saying, but I kind of feel what you're describing should be the duty of the preprocessor.
Should it?
The preprocessor is already changing the program.
Okay.
It's already introducing the conjunction of queries. It's already creating a declaration with an empty name and making the query with the conjunction to be the empty the predicate. It's already adding code, like virtual code to the thing anyway. Which, by the way, that's not going to work anymore, right? In the beam. You cannot make a function with an empty atom as the name, can you?
With an empty atom as the name. Why not?
Wait, do they allow you to do that?
I mean, um,
There's no way. Okay.
yeah, it does.
Okay, so this is not we can say that we copy them then. It was not a jank solution. It was already genius from the start.
Why rare?
Okay, anyway, so I think because here's another thing, Marinho. We are adding a third pass to this thing. We had the first pass, which is like parsing, like lexing and parsing. Then we have the
Mhm.
preprocessor, and now we are adding more passes in the compilation pipeline.
Yes, we're adding desugaring of the unifications on the argument list.
Exactly. And no, I think that if you're gonna do that instead of doing the second option, why not just do it in the preprocessor anyway? What do you think?
I mean, we could. We definitely could.
Okay, let's do it like this then. What do you think it's gonna be faster to have like a proof of concept first? Doing the compiler or like pausing that, adding that to the preprocessor?
Let me think for a second. Hmm.
Yeah, and this is also very not optimized, the preprocessor. It's doing already three passes in the preprocessor, and if you go all the way to the bottom. There's a filter
I'm,
map, a map, a group, and a concat map.
uh, it would probably be easier to do this in the preprocessor, actually. Okay, so concretely, what would we need to do to implement this? We need to collect all of the variable names in the argument list and the body.
I
Um,
think we can do it in the process of creating multi-declarations. Like throughout the process of grouping them, we can already do the thing.
I mean, technically, we can do this. We can do this even before we do the multi-declarations. In
Yeah,
fact.
no, but I'm trying to optimize. Like we already have 5 passes in this shit. Let's try to keep it 5. Oh, you could also make the argument that we should not be using lists and should be using finger trees anyway.
That doesn't help because all of these are collection operations. The big O doesn't change if we use finger trees.
Wait, but the big O isn't like n log n in finger trees? All of those?
No, mapping and concat mapping and filtering, those are all linear actually. Same as lists.
Yeah, actually that makes sense. So it doesn't matter the finger trees. Well, anyway.
The big yeah, the big deal with finger trees is that you have access to the end of the list in
Yeah,
node 1,
appending is easier. Yeah.
and concatenation and slicing is logarithmic as well.
hmm Well, anyway, what do you prefer? Do you want to make a separate, a sixth pass to the party just to do this, or can we maybe put it in the multi-mapper or something?
Mm, that's a good question. Find variables. We already have a find variables here. Where are we using this?
Yeah, this is exclusive to the preprocessor.
Parser to compiler.
No, this is grabbing a parser clause. Okay, this is actually doing the
Oh,
conjunction and everything else.
oh, right, because we need to grab all of the variables in the query to turn them into arguments for the query
Yeah, yeah,
predicate.
yeah. Which is kind of the same vibe of what you proposed.
Yeah, this is kind of halfway there already. We already have find variables, and then we just need to use it to say, okay, I want to generate a new local
Yeah,
variable that's
halfway there, slash, like not really, because this is specifically implemented to queries. We need to do the same kind of process to the declarations.
I mean, we can just reuse this function, yes, but yeah, the actual logic, we need to do it slightly differently. Um, I think we should be able to just do it here, actually.
Should we? Let me think a little bit. Yeah, actually that's okay. So what do? We need to grab the head of it and do find variables on it, maybe?
No, we need to do find variables on the folder left, folder, blah blah blah, funcs. Yeah, we need to do basically this. On the multi-declaration, body and also the head.
Yeah, which we do have. We have inside the decal.
Which we do have, yes, it's in here. So you grab the body, grab the head, find all the variables in both of them, and then we iterate over the argument list. And anything that's not a variable, we generate a fresh variable name that's unused anywhere else, and we use
Change
the
the body
set
of
of.
the declaration to also like do the equality, which means that the equality needs to be a built-in now.
Yes, but also it means, well, on the runtime we already have unify, which is what equality is supposed to do. So yeah.
Okay, that sounds like a plan.
Man, dude. Like, I'm in territory that I don't know what to do. I think I'm crazy.
Well,
Like, I implemented a sketch of the thing, and then I dumped a file, the one I was writing, to a prompt, and then I said, generate documentation. And then it produced the docs, and then I opened to read what it produced, and it's just trash.
oh,
Like,
that's the reason you think you're crazy?
man, this is funny because I know it doesn't have a lot of resources to understand the nomenclature, which is most of the issue, I would say. Like when you say domain, like it's not thinking of the set
See
domain,
you,
right?
8 a.m.
It's thinking of the right. So it's thinking of the uh,
Thinking of the.
sorry, it's thinking of like types, right? Of normal like
Yeah,
types
you
in
need.
a
Okay,
actual
but here's
language.
the thing. These very obscure and nerdy things, you need to teach the AI, dude.
Very
That's the
carefully.
reason. That's the reason that Bellani, before he was showing to us his conclusions with AI, that there's like a bajillion interactions teaching the thing.
Yeah. Man, I'm very disappointed actually because I expected it at least to know, like to be able to infer based on the closed text that I sent it because I chewed up, right? So I had the actual document that I know is not easy to grasp. So I tried to clarify it, rewriting a bunch of stuff. I fed it. I told it, ask me questions about it and try to understand and like give me the summary, and it was fine. I mean, a bit sloppy, but fine. And then I asked it to document the code I wrote. It just like butchered everything.
I see. You're still writing the thing in Erlang, right?
Yeah, it's
Awesome.
still Erlang.
Marinho, so I'm guessing you wrote that to do is because you're tired. You're tired, right? You have to eat something probably.
Yeah, I'm gonna stop to eat. I'm actually going to commit what I already have here. After eating, I may actually continue because this is pretty interesting, actually. So,
Where you guys are stopping right now?
Okay,
Just
so
so I know.
let me explain. Okay, let me try to explain because then Marinho can check if I understood. Go to this
okay.
file, please, Marinho. There, that the one that the cursor is. Yeah. Okay, so here's how it works, Magito. We have the compile function that is
Mm-hmm.
essentially calling a smaller function doing like this is a list of things. Then there's the base case. The output is essentially the list of beam types that you and I implemented and Marinho tweaked it for the better. And then we have line 81, which is essentially the case that matters. It's calling a function called compile form. The compile form checks if it's a query or a multi-declaration. If it's a declaration, line 74, we go to compile a particular declaration. And then this is actually where the extra sauce lives. So this is where it really starts the translation between a Karuta predicate and an Erlang function. So for starters, an Erlang
Okay.
function has extra arguments, not only the variables that were sent via the predicate, it needs to receive extra things. So as you can see in line 62, we have
And those are the arguments for in and out. Is that it?
those are those are bookkeeping things, such as
Bookkeeping.
such as example, the choice points for backtracking mechanism, and the environment for the logical variables. Because again, Erlang doesn't have them, so we have to do the bookkeeping ourselves.
Oh, I see. So you're basically making a relational wrapper around
Yeah, we are actually
any
like
arbitrary Erlang function, right?
exactly we are converting out
How the heck would that work for normal functions, though? You would just apply them in a sequence trying to unify?
I have
Here's the predicates that I hand compiled as
no.
an
He
example
asked the
here.
opposite, man. He asked how are we gonna pick an Erlang function and translate it back to a Karuta predicate.
Yeah, translated to Karuta, right? Like,
Yeah.
I suppose you have to do this automatically. So
Yeah.
Why would
What?
how?
we need to do that?
Well, because we want to leverage the Erlang ecosystem.
I don't know. What we need to do that is define an FFI, like semantics for it. Because right now we don't have that.
Yeah.
But
What?
then if we once we have that, we just say, okay, I'm going to do an FFI call, and that may have some semantics that interact with backtracking. But if it doesn't, we just insert the call to an Erlang function here.
Yeah, we're gonna have to make some sort of protocol to actually convert an Erlang function to a Karuta predicate. That's not right now. What Marinho is showing on the right is the Karuta program on the top. So that's basically plus really logically. And what we have down there on 32 all the way to 53 is the translation in Erlang that does that in Karuta. So how does that work? Line
That
30.
means that Karuta, just one thing, that would mean that Karuta will not ever have functions as first class citizens, right?
I actually, yeah, my understanding is
It could
that,
have.
okay, but my understanding is that we would go relations all the way.
Well, functions are relations too, but
Yeah, yes, but we are kind of like upgrading functions to be relations via the FFI that Manning was mentioning.
yeah, so you always have a wrapper. I'm
Exactly.
just thinking if you don't want to have that such wrapper, for example, because it's if it's not automatic, which I think we
I
will have
think
to do,
I think it will
a
be
huge
automatic.
burden.
No, I think it will be automatic. Well, at least there will be an easy way to integrate that function. That's what I imagine. But I don't have only Marinho knows the details of that. Anyway, so as you can see in line 32, env0 choice points and the 0 they are not part of the argument list of line 28. The
Hmm.
arguments on line 28 are being converted to arg0, arg1, and arg2. Everything else on the left is bookkeeping metadata that we need for the runtime. Okay, then it comes the line 34. As you can see on 28, out is appearing on the first position of the argument and on the third position of the argument. So we need to unify them.
Yeah.
And in this version, they are arg0 and arg2. And the same applies for arg1 and 0. Because in that particular case in 28, the second argument is actually a literal, so we need to unify that as well. In this particular case, the body of this plus is a tail call, so we just call the tail call on 36. Okay, the 28 and 29 are pretty much the same, so I'm going to skip 40. Let's go all the way to 48. 48 is the last choice point. So this is the final attempt to call plus. And this does something interesting. As you can see on line 30, there we are introducing the previous variable inside the successor.
Mm-hmm.
To do that in here, we need to ask the runtime to actually provide us a fresh logical variable. And then how do you differentiate them? Arguments are always args, and freshly created variables are always vars. That's the convention.
Actually, this can just be an equals. I just realized because this doesn't fail.
Yeah, that's true. Then as you can see on 30, we need to unify. We need to unify successor of previous, which is line 51 there at the end, with arg 0. Yes, we are doing that. And then line 52, because this is also a final, there's only one thing to do in the body, we just tail call. And that's it. So this is the translation of the plus in Karuta to the Erlang. Right? And because of the bookkeeping things, now you can go back to the buffer on the left on line 62. We need to do this arity plus extra arguments. And I didn't want to put the 3 there because that would seem magical for people. So I asked my Maninho to actually put a binding just for that on the top. He called it extra arguments. But that's a 3, essentially. Good stuff. And then the final function that we started today, which is compile body. Because here's the thing. Now that we have the compile declaration, we need to compile each individual available implementations of plus. So like we have three versions of plus. We need to compile each one of them. Line 50 is one base case, which is, well, you don't have a clause. 51 is when you don't have multiple versions of the same predicate. It's like a singleton. So there's only like a single plus per se, or like a single equals. And then we implement that. And then line 54 is like the big huge case where plus is going to live, because there's 3 pluses. So you're going to have to do the first clause, then the second, and the third. And then we need to keep track if this is the last one or not, because if it's the last one, there's no else in the maybe, as you can see there. But if it's the first or the second, there is an else, because the unification may have failed. Yeah, I thought that was unreachable. So thank you, Maria. And then what we started to do and to discuss is where in the fuck we're going to rename the arguments. Because we have, when you're writing your program, you're calling out in 28 on the right. But that is not what we're going to use to do our stuff. So we need to rename them. And then we were discussing where we're going to do that. Probably the best way is to do it in the parser level. But for the sake of simplicity, we're going to do it in the preprocessor, which is where we already are like expanding and adding stuff and changing the code and stuff like that.
Yeah, and the reason we can't just use the normal argument list, Marietta, just for the record, is we're doing our own unification, which Erlang doesn't know about, so we can't just reuse this argument list and expect it to work, because it doesn't.
Yeah, it doesn't have logical variables, so it doesn't know how to unify the outs automatically there. Okay, and then the final thing, line 30, you see that there is a successor of a previous, which is not a variable, that's like a structure. We were discussing how are we going to put a name to that. Marinho's suggestion is we actually rename the successor of previous with an entirely new name, and then we do the equals. Do you have the code with doing the equals, Marinho? I forgot.
The code doing the equals.
Yeah, the proposal that you. Oh, let's just create add code.
You mean this?
Yeah, exactly. As you can see, Magetta, on line 8, this is essentially the same as line 6. Do you see why?
Wait, this line that Marinho is highlighting is essentially the same as line 6.
Yeah, do you see why?
Let me see. So one is a suck, prev, blah blah. And the other is an alias of the arg0. The quality of the argument. So when the argument is
not a variable, when the argument is not a variable, we do the line 8 procedure, mechanical.
Oh, I see.
Yeah, so that's where we stopped. This is literally what we to do that we just wrote. because we're
Mhm.
gonna do this in the preprocessor. The preprocessor will
Yeah,
figure it out that, oh, you don't have a variable in the argument list.
Yeah, yeah, I
You
see.
dummy
So
dum
you
dum.
have to expand
Yeah, exactly.
what's the main what's
Yeah,
the main
and
yeah,
we're
because
already
construction.
doing
Erlang,
a similar procedure for the query conjunction anyway.
yeah, because the bean doesn't actually know about our logic variables, so we have to do this at some point anyways, and we
Mhm.
decided we're gonna do this in the preprocessor, which is convenient because we already have these find variables that we're using for something else, but it does exactly what we want. It collects all of the variables in the body of a predicate, basically.
No, a particular expression. It's even more convenient.
Uh,
Yeah, so that's where we stopped. Questions, Magita?
Okay, so this is already the target format, right? That you guys are using with the library.
Yeah.
Uh,
Now it's just a matter of writing the maybes, the calling unify,
yeah, now you
stuff like
just
that.
need to convert the actual code to that, right? That tree.
Yeah,
yep.
that's half of the battle. This is only declarations. We still have to fight the query.
Wait, the query. Oh
Yeah.
man, wait. So how would the query with the entry point work?
Yeah,
You
I
know.
don't that's sensei material. I don't know.
Uh, okay, we need to compile the query into a driver loop because, as you can see, we're pushing those frames onto this choice points list when we do this tail call to net, right?
Mhm.
We need to do this essentially every time that we make a choice point and we can backtrack, right?
Mhm.
But
Uh-huh.
then what's actually going to use this is the query, because the query needs to say, okay, I got unification failure at some point, but before this point I had a list of choice points, so I can try again, right?
Yeah, you can try a
The
different
query
path.
actually needs to do that retry essentially.
Yeah, so here's the thing. The intuition, Mageta, is declarations only add choice points. The queries are the ones that pop the choice points.
Mhm.
Because when I looked at this at first I was like, Marinho, who is using the choice points? We are only adding them. We're not using them. And then the answer was queries we use them. But yeah, I think that's. I'm still a little bit concerned about how tremendously bad the error messages will be with this strategy. But that's a concern for the future us. So that's okay.
Yep.
Whew.
Um,
Okay, I'm
yeah,
gonna finish
that's the
the
plan.
recording now.
I'm going to commit